Now I would like to introduce Ben Cartwright, who will be presenting Building and Expanding the bgp.tools Real-Time BGP Collector. Ben is coming to us today, and this is Ben's second time presenting at NANOG. Ben's first talk at NANOG was Discovering Flaws in BGP Error Handling, presented yesterday. Welcome back to the stage, Ben, and it's a pleasure having you again with us.
Very much. Cool. Cheers. Hi, everybody. My name is Ben Cartwright-Cox. If you saw my talk yesterday, this is going to be a lot more, or a lot less breaking stuff, and more about how I break my own stuff. So yeah, hi. I'm Ben. This is Building and Expanding the bgp.tools Real-Time Root Collector. Rolls off the tongue. So first of all, what is bgp.tools? bgp.tools is a combination of all of my frustrations with all of the other network tooling ecosystem. Eventually, at some point, I found myself annoyed at the ecosystem of tools and decided that the best way to do it was to make my own. Sometime in 2018, I decided to basically make what was effectively a version of the bgp.he site, but that catered to my exact needs. bgp.tools effectively tries to act as a BGP looking glass in real time, but with focus on things like mobile usability and real-time route updates. So I'll give you a quick intro to what bgp.tools is first, so that you can understand the second bit about how I built it and how I'm expanding it. bgp.tools gives you a whole bunch of information. You can just search up an ASN number and get a whole large section of information about how a network is connected. That means upstreams or downstreams or peers, and like extended website information, things like that. It also gives you extended information about prefixes. So if you have a prefix, you can, for v4, you can see straight from the website what lives inside the prefix, whether there's IP addresses that ping, or alternatively, if there are things like v6 or v4, you can see the forward and reverse DNS, which can be very useful if you are seeing traffic to a prefix block, but you don't exactly know what that traffic is. You might be able to look on bgp.tools and see what DNS names point there, and might give you a better clue. On top of that, there is a much more classical global looking glass. So if you're used to things like root views looking into the telnet server, turns out you can just SSH bgp.tools and do pretty much the same thing. If SSH is not your thing, or telnet, we don't support telnet, but if that's not your thing, you can just use the web interface too. Another thing that I focus on a lot is decent information for internet exchange points. So there are two kinds of information feeds. You have the basic stuff, which comes out of PeeringDB and all the standard data feeds as you expect. However, for some internet exchanges, we are much more deeply embedded, which gets you to do things like the vendor things. You can see who is using what vendors on what platforms. And you can also see things like what they're doing on things like the root servers. So if you're curious about, before you join an internet exchange, what peers are sending to what root servers, or what routes they're sending, you can take a quick peek, assuming that bgp.tools is on that exchange as well. Oh, I guess this is, oh, okay, fine. Just look behind the banner, I guess. Another thing that bgp.tools does is things like real-time looking glasses on an individual ASN basis. So if something already feeds bgp.tools, you can use most of their feeds directly as a looking glass, rather than trying to find out where their looking glass is on their website. And if you have a RIPE Atlas account, you can also link their API key to have a sort of real-time or close to real-time interface that's much more MTR-like, rather than using the RIPE Atlas interface, which can be a little bit slow and clunky. One of the much more contentious things is that bgp.tools does network ranking. Only one of the ranking possibilities changes depending on if you feed bgp.tools data, but I would always encourage you to feed bgp.tools data to the root collector. But I support things like the peer count, which is a much more classical style of ranking networks, and may not necessarily be the best. But there are much more salad ones, things like the AS cone, which is similar to how the KIDA AS rank system works. But there are much more sort of fluffy ones, things like estimated eyeball population. So if you're looking for which networks carry a lot of eyeball traffic, you can see that an estimated ranking, or like which ones contain the most amount of DNS records pointing into them. You can also figure that one out. And then finally, if you're looking for the ones that just have huge amounts of IPv4 and IPv6 resources announced, I've got you covered. So the core point is that bgp.tools was built out of frustration that I had with other similar tools. And so most of those things ended up being things like real-time BGP data. A tool isn't very good if it's more than 48 hours out of date. You must be able to change something on your router and immediately refresh the page to get an instant feedback on what's going on. The other thing is around things like whois. Whois is an incredibly difficult thing to parse, as I'm sure some of you might have tried. I spent a huge amount of time of my life writing whois parsing systems to correctly handle all of the horrifying edge cases. And just frequent updated data. So things like the IPv4 internet is scanned every like 30 days or so and updated on the website, and reverse DNS data is picked up relatively quickly. So that's what bgptools is. How do I make the bgptools that I want possible? Because all of the bgptools development is driven by what I have found frustrating. And at the time when I was developing it, there was no sort of proven way of developing what I wanted to make. So there are main challenges. Here are the main challenges running bgptools. First of all, it's getting low latency and accurate BGP data to use, building a scalable system to make sure that I don't have to start making difficult decisions on which BGP feeds I want to accept, because that's just hard. You don't want to do that because it ends up you causing awkward conversations with networks being like, actually, I don't want your data. That feels insulting to some people. The second one is just collecting relevant data. So it's all fine if you have. I'm British, as you can probably tell, so if I collect 100 feeds in the United Kingdom and the United Kingdom only, that's not very useful for a worldwide view. And then finally, if you're running any kind of service, it's pretty important not to go bankrupt. So whatever you have to be doing also has to be relatively cheap and scalable and sustainable to run. So the inner workings of bgptools, so most critically is things like the BGP data. So a lot of the stuff is focused on, the PowerPoint is a little bit off center there, but most of the stuff is filtered on things like the AS path. That might be the most important part to see how the internet works. And so how do you get enough of a sustainable view or non-biased view of the internet from the AS path data? So you have mostly it's speaking before bgptools, there were two major choices. There was RIPE-RIS and there's the University of Oregon's root views. So there are a few problems with this. So root views, they are both incredible projects, but in general, they provide data in two ways. So they have MRT dumps, aka the RIB, the full table dumps, and then the messages files. The table dumps happen, depending on the project, every 4 to 8 hours, which can be good. If bgptools started on RIS and root views and would basically update the site every 8 hours, because that was the maximum time for each table feed. But also they provide this thing called the messages files too, which is effectively a MRT wrapped version of the messages that are hitting the BGP collectors. So unfortunately, these have a little bit of quirks attached to their data sources. So first of all, as mentioned, the table dumps only show up every 4 to 8 hours. Sometimes they don't show up, which is very bad. It makes it also very hard to remove individual sessions that are either accidentally sending bad data or leaking internal routes or stuff that you don't want to actually see. It makes it difficult because you're not in control of those BGP sessions. The University of Oregon and RIPE are. The second one is the message dump system. If a message file never shows up, that's actually so much worse than a table dump file not showing up, because if there is a gap in the data at any point, you cannot recover from that. You'd have to wait for 4 hours or 8 hours for a full table dump to come back and then reload from the ground up. That's not very good, especially if someone is expecting that data to be there. So if your site is inaccurate for 8 hours, which is effectively an entire working day, people aren't going to trust you. The other issue is that a lot of these root collectors suffer from people accidentally misconfiguring their routers and flooding a huge amount of update messages in, which means either these message files get quite large, or alternatively they get really just hard to search for. And so downloading these things, especially from the UK where bgptools is based, these files can get big. You don't want to do this. The other thing in general is that because of the way a lot of these projects are sort of set up, they're set up on internet exchanges, and people like Hurricane Electric are a sort of victim of their own success to some degree on this, in that Hurricane Electric sends 180,000 routes to the root servers on most exchanges, which is unfortunate. Well, it's great in that you get 183,000 routes, 180,000 routes for free. But on the downside, that means that when you're trying to get diverse views of the internet and someone is sending 180,000 routes, you're probably going to automatically prefer those routes because they're appearing. And so that hides the interesting transit paths from the collector. So that's unfortunate. So around 2021, after a number of issues with MRT files, I decided that it was time to start my own root collector. So mostly of these issues around things like moderation, like how do you deal with bad data, how do you deal with stuck routes. I have no relationship at that time to most of the people collecting, so I had to go and find people on IRC. I had to email people and be like, hey, did you know that session is stuck? Did you know that there's stuff wrong there? And, on the best of days, trying to find reliable contacts at networks is difficult. So I decided to build my own. This reduced the site's data latency from 8 hours to basically 0. If someone sent me data, I could immediately integrate it. I also decided for now that multi-hop eBGP, so effectively BGP sessions across the internet, was the most viable way to do it, which we'll get onto later. It was also clear that there was no normal BGP daemon that was going to work for the scale that I was looking for. A lot of the root views and risks are effectively giant FRR router instances, and there's scalability problems at some point. You cannot just, I'm sure anyone who has attempted to make a large root collector within their own network, a large scale network, knows that a 64 gigabyte bird or a 64 gigabyte large FRR is absolutely no fun to work with, and things go wrong very quickly. So instead, I had decided to write my own BGP daemon that was specific to the tasks that bgptools was wanting to do. So just to start off, I worked with the NLnog ring root collector project and basically had a copy of their data. So anything that anybody was sending to that system, I also got. And that was an amazing first start, and I'm very thankful for them for doing that. So instead, I built this thing called NeoBGP. So it's a purpose-built BGP daemon for this exact use case. So the exact use case being bgptools is interested in real-time lookups, interactive lookups. When you load a web page, it will go and ask sessions things like, what prefixes are around? What connectivity options do they have? What pairing options do they have? What can you figure out in that time? So the way this works is individual features include things like each BGP session is its own process, which means you can individually upgrade one process at a time, which is extremely helpful, not only because processes can crash independently, because I do write bugs, but also you can upgrade processes one by one, or alternatively, you can upgrade them in a way that you just upgrade you change the binary that will be started for a new session, so you can very slowly step through upgrades, which has been incredibly helpful because when you need to go and reset a huge number of sessions, there is a level of care you need to take to make sure you don't blow up your own system. This also makes sure that multi-threading scalability just happens automatically. If you have 400 processes running on a machine, you can automatically scale to 400 cores without even doing anything. Even if the individual sessions are limited to single-threaded only, doesn't really matter because you're receiving enough data in all angles that all the CPUs just get used automatically. The other interesting thing about NeoBGP is that it just implements no useful router functions. It could never really be used to power a router because it doesn't need to. It's not interested in doing things like best route calculation because it doesn't need to, or AS summaries or things like that. Doesn't need to figure out recursive routes. Also, feature implementation is moved for certain features. They are BGP daemon features, which makes it a lot easier to implement rather than the website collecting these huge volumes of data and processing them on the side. Instead, the BGP daemon answers the questions directly. This allows bgptools to hit what I would call pretty decent levels of scale. bgptools currently sits at plus or minus 10 or 50 because the slides are, I submitted these slides a while ago, but bgptools at the time of writing has about 1,360 BGP sessions established. And that comes out to around 750 full IPv4 tables and 1,210 full IPv6 tables, which totals around to about 1 billion BGP paths stored in RAM and ready to access in real time. While doing that, however, the hardware is extremely modest. The entire site operates inside a quarter cap. In fact, you can pretty much see the total usage of the compute side of that is actually only about, what is that? That's 4U. And so each machine is dimensioned to be optimal for that exact use case. That's 0.5 terabyte of RAM per machine, 32 cores of machine is generally the sweet spot. And right now there are only 3 active machines, and there are 3 more ready to go when they're required. I did a bit of a back of the envelope calculation on how much bgptools would have cost to run on a cloud provider, and came out to right now to be somewhere around $12,000 US a month. In reality, it currently costs somewhere between 15 and 20 times less than that in co-location. In fact, $12,000 is roughly speaking still higher than the entire capital purchase I've ever done for hardware. So we've got those 2 things handled. We've got low latency and accurate data, and we built a scalable system, and we're also not going to go bankrupt. Oh, we need to handle not going bankrupt first. So bgptools funds itself as a sort of semi-commercial entity. Well, no, actually an entirely commercial entity. So the site is funded by offering real-time monitoring services. Because the BGP daemon is specifically optimized for real-time queries, it can also provide real-time monitoring. So instead of your streaming MRT messages files, which sometimes means alerts can take 15 minutes to show up, bgptools can send them out in 30 seconds. which is incredibly preferable because I have been many times personally when I have used such tools, had an outage, stammered, tried to fix the outage, and then the alert comes in, which is extremely frustrating. These are paid premium features. This is supporting the future of BGP tools. This also pays me to work on it. But I won't going to go too far into it because I don't want to turn this into a major sales pitch. So we've covered not going bankrupt. So how do we collect relevant data? Because as previously mentioned, we have 1,360 sessions, but how do I make sure that I'm not just collecting bias towards Europe? When the answer is, roughly speaking, you need to join internet exchanges. I think I at some point realized around the 1,000 sessions mark that I probably hit the saturation for all the networks that are willing to send BGP data over the internet. This is hard for a lot of larger networks as there are ACLs preventing them from communicating to hosts over the internet. And so we need to join internet exchanges. The status quo for RIS and root views, as I mentioned, is they mostly live on internet exchanges. This has advantages because you're already establishing BGP sessions over internet exchanges, and therefore router ACLs and people's automations are much better at handling starting up these sessions. There can be some disadvantages, though. So if we take RIS as an example, RIS has a total of 1,500 BGP sessions online, but only 372 IPv4 tables, which is, even if you account for the fact that you need to set up 2 sessions for IPv4 and IPv6, hopefully you're doing IPv6, then it comes out to an amount of like 779 full tables, which is far off the total number of 1,500 tables. This is because many people peer with RIS, but they have misunderstood the purpose of RIS and don't send their full tables towards it. They're only sending their customer routes. This is not entirely helpful. It is in some degree helpful to figure out root leaks specifically, but it can be hard to go and track down these people and be like, hey, I would actually prefer you to send full tables to this. And getting that communication across is difficult. So when people are setting up eBGP sessions, it's much more clear what they're doing. The other problems with IXP root collection is it's really expensive. If you don't have friendly contacts at these exchanges, the IXP membership fee, the cross-connect fee, the co-location fee alone, combined can make this incredibly expensive. In fact, most of the time, the IXP membership alone can be far more than the actual cross-connect and colo. There's a fantastic website called peering.exposed, which tries to list out the price per megabit of all of the internet exchanges. But if you even just look at the base level price alone, because BGP tools does no traffic on these exchanges, these ports are very expensive if you actually go for them commercially. Even if the IXP can be done for free, the colo cost alone can make this extremely expensive, or alternatively, using a transport provider to bring that in back to where BGP tools can take the feed can be extremely expensive. So I set out on a bit of a mission to get creative on how do you solve the cross-connect fees and the colo fees. So what is the smallest, cheapest, most insane thing that you could ship to a IXP that's willing? And so I searched around and found this. So this is a optic. This looks like a standard SFP optic. In fact, it is. It speaks gigabit, except inside of it is a Linux computer, which is cool. This is cool because you don't need a cross-connect. You just need to give the IXP this magic optic, and the switch is the power supply. So you don't even need to pay for power. You're using 5 watts of their power, or 2.5 watts. It fits within the SFP MSA, so it's fine. And then you can hitch a ride on some of the other providers on the exchange and backhaul data back to London. They're also quite cheap. They're only about $150. They're ARM v7. They have around about the same compute power and memory capacity of a first-generation Raspberry Pi, which is not great, but it's also completely serviceable. It's also completely crazy. So everyone I've offered this to looks at me as if I'm lost the plot. The other downside to this is that this is made by a company called PlumSpace, who was Russian and migrated to a Dubai company since the Russian invasion of Ukraine. But because of that status, I am unsure if I'm able to import more of them legally into the country. And so I had to go and find another solution for these for now. I have a bunch of these still, but obviously if I can't buy more of them, there's no point developing on that platform. There are other solutions though. So you can buy these GPON optics or XGS-PON ONT optics. And so on one end, you stick a standard ONT XGS-PON link, and on the other side comes an Ethernet frame. This thing deframes it all. But there's an interesting thing about this. This also runs Linux. These run a relatively modest 400 megahertz MIPS core, 32 megabytes of RAM. So you're not going to be running anything fancy on this. You're certainly not going to be running high-end Python scripts or whatever. But it makes an interesting programming target to program for, because you're doing true embedded programming at this stage. Thankfully, memory-safe languages like Zig have working MIPS targets for this device. And most of the time, most of these optics are almost ready to go. You need to perform some kernel changes to make sure that, for example, the RX loss signal, when you take these out of the box, only comes live when there is a GPON signal. Obviously, that's not very useful. There will never be a GPON signal in this use case, so you have to do some kernel hacks to make sure that it always pulls that up. The vendor here that I've been working with, which is Leo Labs in Poland, has been really keen and really helpful for me modding these. You can also buy similar technology from this from Huawei, Nokia, FS.com. I think they share the exact same chipset, in fact, probably the same PCB. You can buy these commercially for about $80 US, but note that you still have to do the software mods and the kernel mods to make these viable as a generic compute platform. That being said, it's not a very good generic compute platform. Hey, no thanks. So the general preference tree that I do when I'm working with internet exchanges is basically the following. Most IXPs have things like root servers, and a lot of the root servers these days are virtual machines inside some other part of the rack. So by that, most IXPs have virtual machine infrastructure. So bgptools will happily run a relay in a very small amount of RAM on that exchange. But given they already have the infrastructure to not only put a virtual machine on the exchange, but also normally they have some kind of small amount of internet access. Then I go and offer things like those Linux optics. Obviously, people are pretty scared of inserting these magic SFP optics into their switches, but it is sometimes a very useful alternative. They're also only 1 gigabit only, and a lot of IXPs are sunsetting their 1 gig port service. And at worst, finally, I can sometimes ship physical 1U hardware around if it's viable. But obviously, you want to try and avoid doing this as much as possible because the power costs, certainly in Europe, makes this extremely expensive in the long run. And also, because I am British and because my country decided to leave the European Union, this makes it particularly difficult to ship stuff around. You may have noticed it's not actually possible to store the entire full modern internet table in 32 megabytes of RAM. This is because what actually these relays are doing is they are just relaying the BGP session itself, wrapping it in a multi-path protocol, and shipping it back to London. And so this is because, as mentioned previously, within the Neo BGP infrastructure, for the site to remain usable and snappy, you need all of the BGP sessions need to be about 3 milliseconds away from where the actual web server is running. And so, I mean, recently I'd gone to converge all of the hardware in the same data center, but previously it was spread over a couple of sites. So you need to keep the actual raw latency pretty low to make this enjoyable. That being said, I've managed to recruit a decent amount of internet exchanges. The current deployments are in many countries here. If you happen to be on any of these exchanges, I would highly invite you to peer with me. You can go to the website. We'll get to that later, though. And if you happen to run an internet exchange and you are capable of either taking these magic optics or you've got a virtual machine infrastructure, I'd love to talk to you. You can either find me here or you can email that email address. It'll be on the slides later as well. So we've also managed to solve the collecting relevant data. So the last thing I'll leave you with is setting up feeds for bgptools is really easy. It also helps you increase your peering stats numbers on the site, which can be nice, especially as a sales tool, as people do go to bgptools, it seems, to go and compare networks, which is, I guess, a compliment. You can use PeeringDB to set it up if you have that, or alternatively, you can sign up with your Whois contact details. Sessions are instantaneously provisioned, and you can set up either, if there is an overlap instantly, you can go and set up a full IXP collector session, or alternatively, you can obviously do an eBGP multi-hop. Export to third parties is entirely optional. bgptools at some point will be actually giving data publicly accessible, similar to how root views and RIS works. Root views and RIS works. Unfortunately, I need to get to the point where I can not only serve that bandwidth, but also store that data. But that kind of disclosure is entirely optional. If you want to send data for bgptools and keep it inside bgptools, you can consent to that. And with that, thank you very much. I would like to ask if there are any questions. If not, you can go to the bgptools link and hit contribute data. Alternatively, I'm around for the rest of Nanog, so if you find me in the hallway, say hi. Thank you very much.
Hi, Eric with GigStream. not operator of an IX, but I have a lot of extra room in the data centers where we do peer with IXs. Is that of value to you?
Yeah, it is. As long as I assume if that comes with cross-connect help as well, then that can be very useful. Obviously, from what I understand, the cross-connect fees in the US are significantly higher, at least than in Europe. So that's something to keep in mind.
Okay. Is there any value of being directly connected to somebody that is directly connected to an IX, or do you have to have a dedicated port on the IX?
It's complicated. So generally speaking, I want to be on the IXs itself, not only because it's nice to be on the IX and seeing like what people are doing on the IX, but it also means that I get access to the route servers, which are an incredibly useful piece of information for gauging how big an internet exchange is. So direct connections to internet exchanges are generally preferred.
Okay. If there was an IX sponsor here that would allow for multiple MACs or multiple IPs on the same cross connect, would that be a way to get?
So I've done, bgptools does a few of these sort of arrangements.
Okay, we'll keep in touch.
Thank you very much. Cool. All right. I'll repeat it. Go on, yeah.
Curious why you didn't use RIS Live or CAIDA, C-A-I-D-A, stream.
Yeah. So the question is, why didn't I use RIS Live or CAIDA's BGP stream? That's a really good point. So unfortunately, those things also have the same problem as the message files that I mentioned earlier. So if you lose sync at any point, there's no real way to go back in time. I think actually the BGP stream does have that system because it's a wrapped version of Kafka. But dealing with those failure modes is really difficult. And so if you lose track, especially on RIS Live, where if you've lost the data, you've lost the data. That means that you've desynchronized from the state of the internet, which is pretty fatal. But especially in RIS Live, I don't think there is an easy way to recover from that. And in CAIDA, it requires you to do some Kafka magic, which I don't particularly want to do. Also, it's much easier for me when I have full control over the sessions. I can go to places like Nanog and directly advocate for joining my root collector, versus it's a little bit weird for me to go around conferences and advocate for joining an entity that I don't control. Cool. Thank you very much.